Hello guys, once again, welcome back to you all. Myself Ambuja. Today we are going to start the part third of acid, base and salt chemistry class 10. So here we will start with base as about acids we already had discussed in part 1 and part 2. So without wasting our time, let's start about base. First we will go through the some basic and some natural concept regarding to base. Actually base are bitter in taste. How? Bitter in taste. As like whenever we eat certain vegetables which we don't like, suppose that whenever we are eating a green pumpkin, the taste is same as just like the base, means that they are bitter in taste. And the next thing is that they have the ability, means that bases are capable for neutralizing the acid, means that whenever we have to neutralize acid to form salt, we use base as a compound to mix with the acid, then the resultant value we get the neutralized salt. That's why I told you already why we use eno whenever we are getting acidity. During that time we use eno in order to neutralize the acid present in our stomach. That's why it gets neutralized. Hence we can say that capable of neutralized of acid. So this much clear, guys. Now we are going to see about the common thing which is possessed by every acid. So let's start. Before that, once again I am telling you all how is the video quality coming. Please don't forget to comment, and if you are new to our channel, please subscribe the channel and join the Telegram channel too. So we are going to see about the common features which is possessed by every basis. The major important thing regarding to acids, I told you that they possess H plus ion. What about the bases? Now we are going to see. Before that, let me write some of the bases. NaOH, base is also known as sodium hydroxide. KOH, potassium hydroxide. There are so many. We can take calcium hydroxide. So these, suppose etc. are these certain bases which we are taken over here. Now we are going to see which is the common thing which is present in every basis. Here we can see that every basis possesses OH. Means that they possess the ion OH. Hence how we can say that, means that every basis have one thing as common, means that they possess OH ion. So is it clear to you all? And what about the, here we can see that I told you every basis possesses OH ions. So is it very essential for us to judge whether a given compound is base or something else. Now we are going to see about the types of bases. Even on the basis of a strength, bases are also classified as strong base and weak base. So we are going to see about the strong bases and weak bases. Before that, let me tell you one more major thing is that base is a type of compound, or we can say that bases are having one another property. That base is known as alkali. What is that? A base which can get dissolved in a water solution is known as alkali. Let me write it. Alkalis is a type of base which gets totally dissolved in water. So we can say that those bases which are capable of getting dissolved in water is known as alkalis. Now let me tell you certain examples of alkalis. Then only we will go through the strength of bases. So let's see what is the major thing which we have to consider over here. Let me give you first some examples of alkalis. NaOH, KOH, etc. These all are alkalis, means that they get totally dissolved or mixed with the water solution whenever we put these things in the water. Now after this we are going to learn about strong base and weak base. By this only we will get 100% confusion. We will get 100% clarity regarding to strong base and weak base. First we are going to see about strong base. A base which is totally dissolved or totally ionized in water is known as strong base. Means that the bases which are alkalis are termed as strong base. Therefore, example NaOH, KOH, etc. are strong bases. What about the weak bases? Those bases which cannot get ionized in water is known as weak bases. Weak bases. For example, we can take calcium hydroxide, CaOH, to magnesium hydroxide, etc. are weak bases. Now we are going to see about the characteristics regarding to bases. Means that one by one we will go through every reaction of bases with several other compounds or other substances. So is it clear to you all? Now we are going to see about the characteristics of bases. So let's start guys regarding to the characteristics of bases. Before that, let me tell you one major thing is that we always have to remember only one thing when we are going to study regarding to base. Means that the main thing is that they are always bitter in taste. And one, I think I told you in part 1 only, that ABR and BRB means that acid turn blue litmus paper into red, whereas BRB means that the bases turn the red litmus paper into blue. So this is what is very essential for component for us. Now we are going to see the characteristic one by one. So first one I told you ABR and BRB. ABR is already clear. Acid turn blue litmus into red, whereas bases turn red litmus paper into blue. So we have to remember this one. BRB, ABR is clear already in acid. The second thing is that we can say they are soapy like structure. So we can say that they feel soapy to touch. Another thing I told you, they are bitter in taste. They are bitter in taste. Then the another thing which we have to study regarding to base is that how they react with certain compounds. So one by one we will go through several compounds, and if there is anything left, that let me introduce you about that. Here only I told you 4, but one other thing is needed for us is that base conduct electricity when they are in a solution, means that they are electrolytes. But even I told you acid solution is also electrolyte. The reason behind is that simple water or the distilled water which do not contain any ion does not get convert or does not conduct electricity. That's why whenever we are taking any solution, either it is of acid solution or base solution, they get ions, and because of those ions only electricity can pass, or means that they can conduct electricity. So we can write here they are electrolytes. They are electrolytes, means that their solution are electrolytes. Electrolytes. Up to this much clear. Now we are going to react bases with several compounds. So one by one we will go through that, and even those compounds through which we are used to react acid only, with them only we will react bases also. So let's start guys. Now we are going to react bases with several compounds. So up to this much clear guys. Now we are moving towards that. First we will react bases with metals. How bases react with metals, and which are the products that we have to see when we react metals with base. Now I'm going to react any metal, it doesn't matter, the thing which is already given. So we can take any metal, no matter. But the main thing which I will tell you that how actually bases react with metal. Whenever bases react with metal, we get hydrogen gas as the bioproduct, and even the compound which we get is what? Actually, suppose I am going to take one example only, NaOH, which is sodium hydroxide, which is a type of base. Now we are going to react NaOH with which substance? You can take anyone, no matter, but any element, any metal. Suppose I am taking what? I am taking, it doesn't matter, suppose I am taking zinc, Zn. Then what we will get over here? then we will get the another thing is that we always have to put this arrow mark because it is a sign of chemical reaction. There we have to apply heat as a catalyst delta form. Then we have to see only that whenever we are reacting sodium hydroxide with zinc, then the solution which we are getting over is that sodium zincate. Means that I already told you, whenever bases react with metals, the thing which we get as a hydrogen gas plus salt. So here we will see that the thing which we are getting is sodium zincate. Actually, after writing this, we will balance this equation. Here we can see that in order, here LHS and RHS atoms, number of atoms are not equal. Hence, we are multiplying here 2. Then we will get here 2 Na, means that Na2. And here even we can see that whenever we are taking here NaO, means that here O, NaO, sodium zincate. And now here 2 is multiplied to the whole term there. We can see H2 is a byproduct. But what about this one? Na2ZnO2. So here O also need to be in 2 compounds. So we can write here Na2ZnO2. Is it clear to you all? Because I told you in order to balance this equation, we multiplied here by 2. Then we got here H2. Then Na2. Zn is only one atom. So one atom. But oxygen here O2. Hence this one is known as sodium zincate. Sodium zincate, which is a salt solution. And the another thing is that hydrogen gas. And I already told you that we doesn't have to consider only those examples which are provided somewhere else, but we have to apply our common sense, and we have to always perform a lots of reaction. Then only you will learn more and more. Now we are going to see the reaction of bases with any another compound. Suppose you guess which compound we are going to deal. Here we can deal anything, but now only we are going to deal with how bases react with acid. Base plus acid. Here I told you, whenever bases react with acid, we get salt. But is there any more thing that we get apart from salt? So guys, let's see. Suppose we are going to take by an example only, then only you will understand better. And not before that, let me tell you one major thing is that I had asked here one question from you all guys, that whenever bases react with acid, we get salt as a byproduct, one solution or one content. What about another content that we get over here? Let's see by an example only, then only we will clarity over 100%. Suppose we are going to react NaOH, same, plus acid. Suppose we are taking here H2SO4, sulfuric acid, and we are going to perform a reaction between these two, base and acid. And here we can see that what we will get here, bottom, means that H2O must be over there. And now look here, NaOH, H2SO4. So how we can write it? We can write it over that Na. So we have to multiply over there. Then here SO4. So we can write here Na. SO4 means that sodium sulfate plus 2H2. This is what our reactant value. But we can see that this equation is not balanced. So we can check here. Na means sodium. Sodium is of one atom. So we are getting also here one atom, no problem. But here we can see that OH is 1. Or here O is 1 and H is 1. And here H is 2. So finally we get here H is of 3 atoms and O is of 5 atoms. Is it clear to you all? And here we can see that here S means sulfur. Sulfur is in 1 only, so we are here all balanced. But what about 3 and 5? So we are getting over here. Here we can see that the oxygen is over 3 only. So sorry, 2 only. But here we are required to put 5. So we need to do something more. But here we can see that SO4 means that they are a 4 plus 2, 6 we are getting as a reactant, means RHS value, product में 6 है. And now here we can see that 1 and 4, 5th only is there. So we can need to multiply with something and something. Here we can see that here some equations are mostly compacted or they are mostly complex in nature. So here we have to see only the basic form, not the overall their balance, because whenever you will go for balancing, you might get certain confusion. So the main thing is that whenever sodium hydroxide reacts with H2SO4 means sulfuric acid, the thing which we get is over sodium sulfate plus water. So is it clear to you? Now we are going to react as basis with another compound. So think which might be the reactant through which we are going to react. Suppose we are going to take the same thing which we took in acids, is that we took the metal hydrogen carbonate and metal carbonate. So before that, we need to know something more about the non-metal oxide, means that we will react bases with non-metal oxide. Before that, guys, wait for a moment. Yes, guys, everything all right. Now we are going to react bases with non-metal oxide. So we will take one example, base with non-metal oxide, and we will see what are the reactant value that we get over this reaction. Actually, the reactant value which we get is that salt plus water, means that H2O. It is actually the general formula of H2O water. That's why I had not written by balancing it. So don't get confused whenever any person is asking from you whether 2H2O or H2O is same or not. Yes, approximately means that yes, 100% it is same. But the main content is that whether the person is asking as a reactant or as a, we can say that they are asking whether as a reaction or as a general. Whenever they will ask as a general means clear. But whenever they will go through certain exceptional means whenever they are asking from us in case of any reaction, then we have to say no, because there we have to balance and then we have to give a proper resultant value. Now we are going to react base with non-metal oxide. Suppose any base, the main base we always use is that NaOH, means sodium hydroxide. Suppose here we are taking non-metal oxide means CaCO2, carbon dioxide, non-metal oxide. Okay, over. Now we are going to react how sodium hydroxide react with carbon dioxide. So let's see how they react with each other. Now here we can see that the reactant value we have to put over here is salt. So first we will go through their reaction NaCO. Here we can see that Na means sodium, here C means carbon. So how they will react? They will actually do not react, and even whenever we will go to react with them, they may give us certain exceptional case. But suppose how we will find salt from this, means that salt always need to be zincate, sulfate, like that only. So let's see how it is possible to react both of them. Maybe it is possible. Let me check it first. No, guys. So we are going to change and we are going to take a compound or take a base where carbon need to be available over there. So suppose we are going to take any base. So let's take a base which is carbon hydroxide, means that CaOH2. Sorry guys, calcium hydroxide. It doesn't matter, I already told you. You can take any base. Suppose I took here a base, you can also try it. But in that base, we will might get confusion. So whenever you will get confusion, you need to ask from me. I will solve it. So let's start CaOH2, which is a big base as compared to NaOH and KOH, means potassium hydroxide and sodium hydroxide. Now we are going to react both of them. Then we will get here Ca means calcium, CO3, calcium carbonate. Here we can see that CO2 plus O2 means O3, and here only one thing is required, H2 means H2 and O1. So CaCO3 plus H2O means that overall we are getting here salt and water as the reactant value. And even let me tell you one major thing is that in most of the cases we don't balance the equation, but in certain cases where it is essential we already go for balancing, then only the concept or our reaction is 100% correct. So guys, What you all are thinking? Everything all right? Now we are going to see the last thing about their uses. So guys, one by one only, slowly I'm going. That's why only, because most of the people had commented me that they asked me that I am not going through the concept. So I'm just going through the concept only. Base. Now we are going to see their uses. Actually, look, bases are mostly used in first case. They are used as which case? They are used for neutralizing. Means that we can say that they are used as neutralizing agent. First one. What about second one? Actually, bases are also used as Colgate paste. Colgate or any paste we can say, yeah. Toothpaste we can say, okay. Toothpaste. Actually, before that, let me tell you why we use toothpaste. Why there is base present in toothpaste? Because whenever we eat food particles, there the acids present in different food particles get attached to our teeth, and whenever we pass through bases, means our toothpaste, then they neutralize the acid present on our teeth, and finally our teeth gets protected from the microorganism, means bacteria and several other organisms. Now we are going to see another thing is that how they are used. Even I told you one another thing is that wait guys, wait. I already told you in nature only that they are soapy in nature, means that they might be used for making soap. So is it clear to you? Soap, paper, synthetic or rayon. Before that, let me tell you about one major thing here that I am going to tell you about. What is that? Soap, paper and rayon. Let's think how bases make these all particles. Actually, I told you bases are mostly soapy or slippery in nature. That's why they can be used as soap. Okay. What about paper? Paper is also okay. What about rayon? Even when you will go to see rayon, they are also somewhat slippery in nature. So we can say that there might be bases available over there. Now I told you another thing, which is the calcium carbonate, which we use as our home whitewashing. There also be used bases. So we can say that there are more and more uses of bases. So here we can't go through any one base or any one we can say that we can't go through any one use only, because so many uses are there. But the main concept we are going to see about the strength of bases and acids. This is very essential, and you might be asking this only from me. So let's start and see the strength of acids and bases. Actually, I told you, in order to classify whether the given solution is acid or base, we take litmus paper and we get clarity whether a solution is acid and base. But what about those in those conditions where we have to find the strength of acid? We already knew that this solution is acid. Now we have to find over there is that whether this solution is a strong acid or weak acid, or whether this base is of strong base or weak base. So we are going to deal with that, means that how, which scale or which type of instrument or which way we can use to check whether a base or acid solution is powerful or not. So we are going to see strength of base and acid. And after this, you will see a very interesting thing, which is pH scale. What is pH over here? The most important thing is that first we need to know about its full form only. Actually, P means protein in German. But what about our local language? P means power. And what about H? Means power of hydrogen ion. Or we can say that pH refers to actually the power of hydrogen ion concentration. So this much over. We can say that pH refers to the power of hydrogen ion or the power of hydrogen ion concentration. And now the major thing we are going to see about that, who had discovered pH. Actually, the pH scale was discovered by Sorensen in 1909. So it is not very essential for you all because you are in class 10. So most of the students get confused whether the history type questions we need to revise or no? No need of revising those questions. Only the basic concept regarding to chemical world you need to go through. Now we are going to see about the strength of acid, then we will go through the strength of base. Actually, let me tell you that we are already familiar with that every acid solution contains H plus ion. Means that here let me write OH minus and H plus. OH minus and H plus. Now let's see about their strength. Before that, let me tell you that every acid solution contains H plus ions. Means that there is always hydrogen ion is available over there. But what about the strength of those acids? How we can say that whether HCl is powerful acid and whether a sulfuric acid or another acid is less strengthened than the HCl. So let's start and see how we can say it. Even the main thing which matters for is that the concentration of H plus ion. Means that how much H plus ion is available over there, because there you will see that we can say that the concentration or the number of H plus ion is more than the pH value of those acids or those solution will be less. मतलब यहाँ पे एक बस इतना याद करना था कि pH is inversely proportional to the 1 by what we can say here H ions. H ion means both, whether it can be hydrogen ions or hydronium ions, means that OH ions. So guys, this much clear you all. And now we are going to see whether any solution, suppose we are going to mix acid HCl with a water, with 5 gram of HCl is mixed in a beaker of 100 ml of water. So here we can't say that only H plus ion is available over there. No, even in water, H plus ion and OH ion both are available in water, and then only they form this equation H2O. Here we can see HHO means H2O. And finally, the major thing is that we can't say the water contains only H plus ion or the solution of acid contains only H plus ion, because OH ion is also available in every solution, whether it is acid or whether it is base. But the main thing is that H, whether if it is acidic solution, then H plus ion will be more, and if it is basic solution, then OH ion will be more. Now the main thing is we are going to see about that their strength on pH scale. Here we are drawn, actually in case of pH scale, the value differs from 1 to 14. Actually 1 to 14, there every scale or every value has different color. So let me tell you, 7 is considered the neutral, and the left side of 7 tells about the strength of acid, whereas the right side of 7 tells us about the strength of base. Wait guys. One, two, three, four. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now look here. I told you that if more hydrogen ion is there, then the acid will be less powerful, and less hydrogen ion means acid is of more powerful, means that their pH scale will be more. तो देखो भाई, सबसे पहले कि हमारा जितना भी एसिड्स होते हैं वे तो स्ट्रॉन्ग होते हैं, वो 1 to 3 में होता है. मोस्टली 3 में नहीं, आप 1 2 को ले सकते हैं या 3 को भी माने. लेकिन ये जो हमारा 6 5 ये सब का कैटेगरी का एसिड्स होते हैं, मींस दैट दे आर समवट लेस पावरफुल एज कंपेयर टू द strong acids, and even their color also matters. If you want to get a color diagram and with the explanation, you need to join our Telegram channel. And what about the bases? If more bases solution, more basic solution means more strengthened solution gets over here, and the less one is of here. So how is this particular video guys? Here we are going to drop this video, and here I had just dealt with your concept only, and how is this quality coming? Please comment me in the comment section. Thanks for watching. Have a nice day. To all. Meet you all in the next video guys.